All right, let's look at cotangent. So here's what we need to know about cotangent is it is kind of opposite of tangent. So with tangent we had asymptotes at negative pi over 2 and pi over 2, and that's not going to be the case for this. What we're going to do is we're going to have asymptotes at 0 and at pi. This is for our parent graph cotangent. So at 0, then over here at pi. And so our graph is going to be in between 0 and pi. Halfway between 0 and pi is pi over 2, so that's going to be our through point. But cotangent is one of the ways in which we can think of it as being backwards is it goes up and to the left and down and to the right, like a negative tangent graph would. So it goes through pi over 2. It has asymptotes originally at 0 and pi. So if we graph another period of this, either we can go to the left and go to negative pi, or we could make this go out farther and make it go out to 2 pi. So whichever we want to do. So here, this middle point is really far out there, 2 pi. Well, between pi and 2 pi is 3 pi over 2. Sorry, I lost. For some reason, I was thinking that was 3 pi. I was like, wait, that doesn't work. And then asymptote here, up to the left, down to the right. Middle here, negative pi over 2. Okay, but what's important here is that it goes through pi over 2 normally. But really what's more important is that we know where the asymptotes are normally at. They're normally at 0 and pi, and then we can adjust from there. If we horizontally shrink or stretch, we move those asymptotes. The 0 one should stay where it's at unless we're shifting, but pi will move either left or right, either closer to the y-axis or farther from the y-axis. It goes up to the left and it goes down to the right normally. If it's negative, it would get flipped so that it looks like tangent. And the period is normally pi for this one as well. So if we want to do vertical asymptotes, then x equals, we pick an asymptote, so you could pick 0, you could pick pi, you can pick any of the asymptotes we have listed. Then we add to that every interval where there's an asymptote. Our asymptotes here are pi apart, so we do plus pi k, or k pi, whichever way you want to write that. And that's where k is an integer. So remember, this means k is an element of the z represents the set of integers. So let's try something a little bit more complicated. Let's try graphing y equals 1/2 cotangent 4x. Well, let's talk about what these things are doing. This is a vertical shrink by 1/2. I actually meant to make this 1/4, like a 1/4 x, or an x to the 4th. I mean x over 4, because I wanted this to actually be a horizontal stretch, because in the tangent video I did a horizontal shrink already. So pretend that's 1/4, so a horizontal stretch by 4. Okay, so what this does is, for one thing, our period is pi over 1/4, so we flip that up and multiply, which means the period of this cotangent graph is going to be 4 pi. We draw our x and our y-axis, and normally our asymptotes are at 0 and at pi, but what we want to do is we want to multiply both those numbers by 4. Well, 0 times 4 is still 0. And then 4 times pi is 4 pi, which means our asymptote will be at 4 pi. So halfway in between there, we should be going through the point 2 pi, so it goes down to the right and up to the left. And then we can make another period over here on this side at negative 4 pi and negative 2 pi. Okay, but what matters is that we have to remember, normally our asymptotes are at 0 and pi, so we multiply by whatever stretching or shrinking factor we have, and that tells us where our new asymptotes are. So that told us it was at 0 and 4 pi. So here our vertical asymptotes are, we pick one like 0, and we add the period, which is 4 pi k, or 4k pi, or whatever order you want to put that in, where k is an element of z integers. Okay, so this is one of our asymptotes is at 0, then we add how far apart are they? How far is it from 0 to 4 pi? Because what we're saying is that every 4 pi after this, we end up with more asymptotes every time. Every 4 pi is going to happen before and after. So that's graphing cotangent.